Okay, we're sketching the cosecant graph, but it's y equals cosecant 2x. So the steps that we're going to follow are that we first sketch y equals sine of 2x. And to do that, we have to keep in mind that the period is 2 pi over 2, which is pi, and that our quarter period, well, I'll just write as p over 4, is pi over 4. And so it's not shifted left or right, the sine graph. So we start at x equals 0, and that's going to give us key points where we always, okay, our first key point is 0, because we haven't shifted it right or left. And then what I'm going to do is I'm just going to add the quarter period. So I have 0 plus pi over 4, and then I'm going to get 2/4 pi, 3/4 pi, 4/4 pi. And those, can be reduced. All right, so, there's other ways to do this, so whatever might work for you is fine, I think. But what I'm going to do is I'm going to sketch maybe, a little bit more lightly the graph for sine. And the thing is, I didn't do this to scale. But see, I did all these stuff over here, key points and quarter periods. But the big thing is once you get the period as pi, if you want, you can just look at this and say, well, look, by symmetry, the midpoint between 0 and pi is pi over 2. And the symmetry between 0 and pi is then pi over 2. But my idea of a quarter period is I know if I'm starting at 0, I just can add, oh, I wrote this wrong here. The midpoint between 0 and pi is pi over 2, and the midpoint between 0 and pi over 2 is pi over 4. But once I get that 1/4 of the period, I can just start at 0 and add 1/4. So it's 0, 1/4, 2/4, 3/4, 4/4. And whether I want to, write this all this stuff, which is, I don't know, it's sort of not, yeah, it's all right. It's not that neat though. Okay, and then I'm just going to use symmetry to go the other way, actually, because I think I should have more going on there. So I think I should have more than just one cycle of the graph. Okay, so what's going on here is this is y equals sine 2x. Now, okay, we have to know for this whole thing to work that cosecant is the reciprocal of sine. So the cos do not go. The cos don't go. Cosecant, a co, does not go with cosine. The cos don't go. All right? Now, what we're going to do is we're going to draw vertical asymptotes. Where do the vertical asymptotes go? They go where the sine function is equal to 0, because the form is 1 over 0 for vertical asymptote. 1 over 0 is not a number, it's undefined. But that's the form where we look for a vertical asymptote. And sine x is equal to, sine 2x is equal to 0, where we have x-intercepts on the graph of sine 2x. So we don't really need to do a calculation to find where sine 2x is 0, because we already have the graph. I guess that was our calculation. And this graph keeps going and going, but at some point you have to decide where to stop. For sine, it's periodic. And we draw these loops, and it should touch where the loop's coming from. Let me just briefly say, where I'm holding the pen, well, it shouldn't be really exactly like that, but let's say I'm holding, okay, you can't see where I'm holding the pen. Say I have this point right here where I just put a little dot there. say that y is 1/4 on the sine graph. Well, this part in blue is, that part in blue is the cosecant graph. Okay. Getting distracted on that. Gosh. Okay. So I have this little point here. I'm going to put in blue. Say that point is 1/4. Well, the cosecant graphs, that's y for 1/4 is sine. The reciprocal of that is 4. So that should be up here. Well, I mean, it's not exact anyway. So it could be better. So I take, so I have 1/4. The reciprocal is 4. So that ends up here. Say I have 1/10 here. The reciprocal of that would be 10 up here. Over here, y for sine is 1. The reciprocal of 1 is 1. So when you get to 1/2, the reciprocal is 2. All right, and that's our, anyway, that's the whole thing. That's all.